Last week we learned about a MOSCAP, which means a capacitor formed with metal, oxide, and silicon. It is because it is important because a MOSCAP structures is uh, very important for understanding MOSFET, which means a metal oxide silicon field effect transistor. So on most capacitors, we can draw a energy band diagram like here. On the metal side, or a polysilicon with n-type heavily doped, the Fermi level and conduction band level is almost the same, and there is a work functions on metal or uh, metal gate, and there is a dielectric which is consists of a SiO2 silicon oxide, and it has a 9 electron volt to jump up and go through the gate to substrate. The substrate is opposite uh, carrier type or beside on gate gate gate. So the Fermi level of the substrate is close to the valence band, which means it is a p-type substrate. On the thermal equilibrium state on a MOS capacitor, we can draw like this, because at thermal equilibrium state, the Fermi levels becomes equally lined because it has the Fermi levels is dependent on a uh, thermal T. So the concentrations of the holes becomes lower, like to the dielectrics becomes lower to closer to the dielectrics. So we can to use these MOSCAP functions, to use capacitors like behavior, we can use the reverse. We can get a reverse bias to the MOSCAP by giving a reverse bias to the MOSCAP. The original conduction levels and valence levels becomes go up like here, and also to get a same offset of the material property, like a work functions of the metal or a p polysilicon, n-type polysilicon, and the p substrate. The vacuum energy levels also goes up. So by giving a reverse bias, the Fermi levels also goes up. So the gap between the Fermi levels and the valence levels, conduction levels becomes narrowed, so that they can electrons can get accumulated by the substrate and dielectric surface here. But however, the holes becomes the concentrations of the holes gets low. So here in the on the metal side, because the dielectrics becomes a polarized by here as the electrons gather here, and the depletion resistance sets on here. So the electrons concentrates goes down on the surface. So that's the how the MOSFETs acts like the capacitors of an electric passive device here, so that we can say like here,